in our structure. All right, it has become a routine, all right, these days, where buildings are being converted to other functions, other usage, all right, aside of what they are being designed for. Because as you know, buildings are classified. There are residential buildings, there are industrial buildings, there are, different classes of buildings. So, and their life loads also differs. All right, their life loads are also differ. So when you're now considering a particular structure for another purpose, it means that you must consult the structural engineer, all right, who will now, look at the design and probably redesign that structure to suit the intended purpose. There are also situations where maybe when you get to site and you want to start construction, you see that the client comes and try to alter based on his own choice, try to alter the provisions in the design. It is not proper to adhere to that. Okay, you have to redirect those adjustments back to the structural engineer, the designer of that structure, who will now make provisions for those additional, features in that structure, so that it will not lead to overloading of that structure. Because once a structure is overloaded, you will see that it will lead to structural failure. Okay, it will lead to structural failure. So one of the effects of overloading a structure is it will lead to structural failure. Now, when we talk about structural failure, basically we are looking at a scenario where those components, those structural components that are meant to carry load and transfer load, are unable, okay, to do so. When that happens, we refer to that as a structural failure. All right, and progressively it will lead to collapse. All right, so it's important that we ensure that our structures don't fail. All right, we try as much as possible for our structures not to fail. And how to do that basically is to ensure that our structures are not overloaded. Okay, because once structures are overloaded, it means that you are directly stressing or overstressing, okay, those structural elements. And that takes us to the next point, as an effect of overloading. It leads to overstressing of our structural elements. Now, these structural elements are like your slabs, your beams, your columns, okay? Because foundation is usually the receiving end, which eventually gets to the soil. So, but basically, we are looking at the slabs, the beams, the columns. Now, when these structures are overloaded, it means that these various structural elements will be stressed, they will be overstressed, they will be working, their functions, okay, will be impaired because of the excess or additional load that is imposed on them. Like I said earlier, that before we do our construction, design of that structure will be done. Now, the design of that structure basically is to get an anticipated load for that structure. Okay, now we design that structure based on the anticipated load. Now, basically, design is to now look at the expected load, then design that based on that load and provide materials, okay, that can be able to sustain that load without any form of failure. All right, so in a situation where you have additional load, okay, that is not designed for, it means that you are overstressing those structural elements, and that can be, described as overloading of that structure. Now, overloading of that structure can come in the form of, having a structure, containing or accommodating more than expected. Okay. For example, if you have a structure that is designed for 500 capacity, okay, 500 capacity. Now you now see that structure after construction accommodating over 5,000, 6,000 capacity or number of persons. You see that irrespective of the size, you see that that structure or those components that are meant to carry the load are overstressed. Okay, they are overstressed because those additional loads are not designed for that structure. Okay, so when that happens, that structure is being overloaded. All right, so we must take note of that. Now, peradventure, we have additional load. It's important that we refer back to the designer, okay, the structural engineer that designed that structure. We get back to that designer, okay, do briefing on the new modifications that need to be done in that structure. If that structure is still under construction, there is still room for modification, all right, depending on the stage that structure is at that point in time, all right. But the most important thing is that you must consult the structural engineer, the designer. You give him information as regards to the modifications that needs to be done in that structure, okay. Then he will have to redesign that structure to suit the current need for that structure, okay, so that you will not have room for overloading of that structure.